Hello, everyone. Welcome back. So today we're going to talk about solving polynomial and rational inequalities. We'll explain what each one of those is, and then our goal is to be to solve each type. And we're actually going to focus on solving them graphically. There's a way you can solve them by hand, but I think in this case, graphically is more useful because that's what you're more likely to do in real life if you have to do anything like this. Okay, so a polynomial inequality just looks kind of like this. We have a polynomial on one side, and we have both sides, and you just have an inequality symbol. So basically, the point, this is not a linear inequality since you can't necessarily get x by itself as you would like a linear inequality. So we have to need a different approach. Then we also have what's called a rational inequality or fractional inequality. It involves a rational function. So it looks something like this, where you have, it's rational in this case because you have x's in the numerator and denominator. And so for a similar reason, we can't just get x by itself. So we need to solve this in some other way. So what we're going to do for this is actually solve them graphically. And what I mean by that is that we graph, essentially we're going to get one side, we get an expression like this, get one side equal to 0. Okay, it's not already like that. In these cases, already in that form, but might always be in that case. Get one side equal to 0. We're going to essentially call the left side f of x, like you see here. We're going to graph that. And then if where the graph is above the graph or f of x, that side is greater than 0 when the graph's above the x-axis. It's equal to 0 when it touches the x-axis, and it's less than 0 when it's below the x-axis. Okay. Now the graph the sign can change at zeros and also at vertical asymptotes. It often does. It isn't guaranteed to, but often changes those places. And then once again, we do that, we find those locations, write our solution in interval notation. Let's take a look at a couple of the polynomial inequalities first and see how they work. And actually, we'll start with this one. So directions, I'll say to solve. So number one, let's just do that. X squared plus 2x minus 3 is less than 0. So we're going to call the left side f of x. And we're going to graph it. Okay. And we'll do that using Desmos. Of course, you also use a graphing calculator if you prefer. Desmos, DESMOS.com. And this one was x squared plus 2x minus 3. So y equals x squared plus 2x minus 3. Okay, now we can see it's a parabola. And not only is it a parabola, what we can see is that basically we have zeros, okay, where it crosses the x-axis. That's what's interesting, that's where it can change sign. So if you're on the x-axis, the function is 0. That's why those are called the zeros, or x-intercepts. Then if you're below the x-axis, that's where this function is negative. If you're above, that's where it's positive. Okay, so let's come back. Let's do a quick graph of that below. So our function looks like basically like this. Okay, so this point right here was 1, 0. This was negative 3, 0. It crosses the axis. Okay, now looking for then is where it's less than 0, where it's below the x-axis. So where is f of x? And we're going to call it f of x on the left side below the x-axis. And we do that in terms of x. So it's below the x-axis between negative 3 and positive 1. Okay. Then our solution, and also in this case, we're looking at specifically less than. Okay. So our solution is just negative 3 to 1. And then since we're strictly less than, use parentheses there. Now, if been less than or equal to, we'd use square brackets. Okay. And also been greater than, then it would add basically, if it said greater than 0, it would have been to the left of negative 3 and to the right of 1. Okay. In fact, let's do that below. Just do number 2. Let's say we have x squared plus 2x minus 3 is greater than or equal to 0. Okay, so we use the same graph, it's the same function. Okay, so where is it greater than 0? Where is it above the x-axis? Okay, and we can see that in our solution, that's where it's above the x-axis and also equal to 0, all right, is to the left of -3. So that's -3, or sorry, negative infinity, -3. There's always parentheses with negative infinity. In this case, since we can says greater than or equal to, the -3 itself is included. So our endpoint itself is included in this one. Okay. Similarly, this axis over here, where else is it above the x-axis? From -1 to the right and to the right of -1. So it's also, sorry, -1, +1 to infinity. Once again, infinity, always parentheses. And since this case, once it's greater than or equal to, it's the 1 is included. And then finally, the union sign in the middle. So that's the solution of that one. If we just simply reversed the sign, made it greater than or equal to 0. Okay. Let's take a look at another one, another polynomial one. So number 3, a different one this time. This time I want to do this. So we have 3x cubed is less than or equal to -15x squared. Okay. Now, obviously this one is different. Okay. It's not equal to 0. So what I want to do then is get the right side equal to 0. Okay. So add 15x squared to both sides. That's going to give us 3x cubed plus 15x squared is less than or equal to 0. Okay. Now we're going to call the left side, or f of x, equal to the left side and graph that. Okay. We're going to call f of x will be 3x cubed plus 15x squared and graph. Okay. Let's go back to Desmos and do that. Okay. I'm just going to turn this one off. So we had 3x cubed plus 15x squared. Okay. Now, you can see that basically where it changes signs is where it crosses the x-axis. Okay. So on the x-axis, the function is 0. So you have two places at -5 and 0. That's kind of all we care about what's going on. Okay. So -5 and 0. -5, 0, and 0, 0. So this one looks something like this. Okay. Right here is 0, 0. And here, this point is -5, 0. Okay. So where is this one? Okay. So once again, this one is less than or equal to 0. Where is it below the x-axis? Obviously, to the left of -5. Oops. Negative should be inside parenthesis there. So -5 and 0. Okay, right there. And also, since we have the less than or equal to, the endpoints included. So the solution to this, that inequality, is goes from -infinity up to -5. Okay. And since the endpoints included that. Now, this is going to be a bit strange. We have one more place. It says less than or equal to 0. Let's go back to the graph. Okay, right here, it actually passes through 0. It doesn't change sign, it passes through 0. This is going to be just a bit different in the sense that we also have to include, okay, also let me say and over here, and f of x is equal to 0 at x equals 0. So what we have to do then You also have to consider we have a solution just to 0 itself, because what it said is that less than or equal to 0. So this one is where it's less than 0, equals to equal to 0 at -5, and also equal to 0 at 0. So what we're going to do here is put a little squiggly bracket indicating squiggly brackets, unlike square brackets and parentheses. Squiggly brackets mean it's just a set of individual numbers. So here we just have 0, and then put the union right here. Okay, this is actually our solution to this one. Now, if it simply said less than, not less than or equal to, it would just be this interval with a parenthesis around -5. Okay. Now also, let me say one more about this one. Let's call this number 4. Let's actually change this. So how about we just do the same? Let's do 3x cubed plus 15x squared is greater than 0. Okay, let's do this. So it's the same graph, same function, so same graph. Okay, now look at our graph. Where is it? Essentially, where is it above the x-axis? Okay. Now, you notice, now one thing right here, it's actually equal to 0. And also keep in mind, I'll say, but also f of x, this function equals 0 at x equals 0. So what that means is that we're interested in where it's greater than 0, not where it's equal to 0. So here we actually have two intervals. So from -5 to 0, it's above the x-axis. Okay. Then our solution, from -5 to 0. In this case, use parentheses because here it's strictly greater than. Use parentheses. Okay. Then where is it also? Where is it above the x-axis? From 0 then, and to the right of 0, from 0 to infinity. And once again, of course, always parentheses with infinity. And then here, the strictly greater than, we use parentheses here and then union. Okay. All right. Now let's take a quick look at an example where we have a rational inequality. So actually take a look at this one. And also, let me make sure I have enough space here. Yeah, that should be enough. But just a bit more, make sure I have enough space for the next problem or two. All right, there we go. Okay, so we're going to do this one right here. So x minus 3 divided by x plus 2 is greater than or equal to 0. Okay, now this is a rational inequality. We can approach it the same way. Okay, what we're going to do, since it's already said equal to 0, we're going to call f of x equal to the left side, x minus 3 over x plus 2, and graph. Just like before, we're going to graph that. What it does most is turn this off. And so that was x minus 3 over x plus 2. You can call it y or not. That's going to be y equals. Now here, to do this, you want to do parentheses x plus 3 over x minus 2. Okay. Oh, oops, I have that backwards. So x minus 3 over x plus 2. Of course, both could work interestingly. All right. Now, if you notice what happens right here, you have this strange look. Actually, there's a vertical asymptote right here because if you notice, you plug in -2 for x, it would make your denominator 0. So I can actually graph that vertical asymptote of the vertical line, x equals -2. Okay. So that's what our graph looks like. We'll also have a 0 right here at 3. Okay. Vertical asymptote at -2 and a 0 at 3. Let's graph that on our paper. The basic shape. So here is x equals -2, and here is 3. So 3, 0. Okay. As we saw, this function looks like this. If I can draw it fairly straight. Okay. Now remember, graph never crosses a vertical asymptote. Okay. What happens also here, this one's going to be above the x-axis. Always. So basically, it's always going to be positive over here. Okay. Now, so once again, we want to know where it's greater than or equal to 0, where is it above the x-axis? Okay. So where is the function above the x-axis and technically touches the x-axis? Okay. Well, clearly, this is greater than or equal to 0. It's above the x-axis. Okay. On this side of -2, on the left of -2, that's going to be negative infinity to -2, or it's always parentheses with infinity. In this case, since this is a vertical asymptote, it's definitely not included. There's a parenthesis there. It doesn't go through that. Okay. Then, where it's also greater than 0 above the x-axis, from 3 to infinity. Now, in this case, since it actually goes through that point, then since we have greater than or equal to, it actually includes that endpoint at 3 since it goes through it. So we have a square bracket here. Remember, it doesn't go through x equals 2, so that's why we have a parenthesis there. Graph never crosses a vertical asymptote. And once again, we have the union symbol. Okay, let's look at one more, number 5. And let me, the one I want. Okay, this time let's say we have 3x minus 1 over x plus 4 is less than 0. Okay, once again, it's already set equal to 0. So we're going to call the left side f of x and graph that. Okay. All right, I'll turn both these off. So this time I'm going to graph y equals, use parentheses here for your numerator. So 3x minus 1 divided by x plus 4. Okay. Now, similarly, think about a vertical asymptote. This one, if you plug in -4 to this, then that would make this undefined. So a vertical asymptote at x equals -4. Okay. And so this one actually looks pretty similar to, let me actually change this around. Let's actually make this a negative. There we go. Just make it look a bit different. Okay, so I actually need to change this to a positive. There we go. Let's zoom out just a bit. Okay, just to make this look a little bit different. Okay, the other one almost looked too much like the previous one. All right, now where's our intercept? Okay, our intercept is actually 1/3. Right, 0.333. In fact, let me change. Yeah, this one should have been more exposed. Let's just make this simple. Let's make this x. There we go. Yeah, so I actually change that here in a minute. We'll go back. Let's just change this to x minus 1 over x minus 4. That way everything is simple. Okay. So we have a vertical asymptote at +4. You plug in a +4, the denominator would be 0. Then we have a 0 at 1, because you plugged in 1, your numerator would be 0. And so it is kind of similar to the previous one, but not exactly the same. So let's take a look and do that. And also I changed it to, let's erase these and change the new value. So this is going to be x minus 1 over x minus 4. Okay, double check that. Yeah. All right. Now, so since we graph that, then here are axes. Okay, so this vertical asymptote at x equals +4. Then we have a 0 here at 1, 0. Okay, so our graph comes up and goes through our 0. Okay, goes on forever in that direction and this direction. And here, it looks something like this. Okay. Our question was, where is this less than 0? Where is it below the x-axis? Actually, only one place, right here. Okay. So where does it start below the x-axis? Well, here at 1. Okay. Then where does it stop being below the x-axis? Well, it stops basically at, now your vertical asymptote, the graph gets as close as possible without ever actually touching it or crossing it. So essentially it stops at 4, 1 to 4. In this case, since it's strictly less than, the 1 is not included because at 1, it's actually equal to 0. And then with a vertical asymptote, we always use parentheses because it never actually crosses that, can never cross it no matter what our inequality sign is. No matter what our inequality sign is, less than or equal to, the graph can never cross a vertical asymptote, so it can never actually be included. So here, looks like our solution is 1 to 4 with our endpoints not included. Okay, so let's see what we've learned today. So we have what are called polynomial and rational inequalities, which examples look like these. So we can't solve them the same way. We can't just get x by itself as we do like a linear inequality. So we have to do a different way. So here we're just doing a graphical method where we actually graph it and basically see, depending on, determine whether it's greater than 0 or less than, set one side equal to 0, then graph the non-zero side, and then determine from the graph whether it's greater than 0 or less than 0. So just remember that a graph like this, any graph, if it's above the x-axis, it's greater than 0. If it's on the x-axis, it's equal to 0. And if it's below the x-axis, it's less than 0. And we can use that information. Also, we can also use what our inequality sign is, where it contains the or equal to part to know whether or not to include our endpoints. And that's how we can solve polynomial rational inequalities graphically. Thank you. Have a good day.